Well, we have different ways to visualize the data. The very first and basic step in visualizing the data is using a frequency table. Well, frequency table is a table, a compact table that helps us to organize the data. Let us take a look at one example in the note and try to graph a frequency table. So here we have example which asks us to construct a frequency distribution table from a data set. The data set lists the prices in dollars of 30 portable global positioning system GPS navigators. Construct a frequency distribution that has 7 classes. Very well. So first of all, take a look at the data. You have different numbers and they are not written in order. You have 128, you have 100, you have 65, you have 132, you have 90, you have 340, and so on. So these are the data that you have. These are the things that you have collected. Let us go back to the board and go through steps to construct the frequency table. In constructing the frequency table, we need some basic information. The very first thing that you need to do is to find the class width. So step 1, class width. To find the class width, you need to find the minimum value and the maximum value in your data set. You need to find the maximum and subtract the minimum value from the maximum value and divide it by the number of classes. Okay. The maximum minus the minimum is also called the range of the data, divided by the number of classes. So let's take a look at our data. What is the maximum value? What is the minimum value? Do we have any information about the number of classes? So take a look at this. By looking at the data, we see that, hey, the maximum value is 340 and the minimum value is 65. So we have the range. We also know from the example that we need to have 7 classes, 7 rows. So let us go back to our board and find the class width. We have 340 minus 65 divided by 7, which is approximately 39.29. Guys, to find the class width, always round up. Always round up. Round up to 40. Always. This is 39.29. And I say, hey, based on the math rules, it should be 39. But since we are in statistics and we are finding the class width, we always round up to 40. Very good. After finding the class width, we need to find the frequency of each class. Well, how do we find each class? In step 2, let us build each class and their frequency. So let me construct the table and show you how to construct or build each bean or each class. Very good. So since this is just a table, we're going to have a horizontal line. We have some vertical line, but step by step, one by one, we're going to build each one of them. So first, your first column includes classes or beans. Your second column going to include the frequency or count. And then we move forward to the midpoint. We also need the relative frequency. And finally, we have the cumulative frequency. Okay, very good. The lines are a little bit tilted. That's fine. You get the big picture of what's going on here. So our very first class starts by writing the minimum value. Remember that the minimum value was 65. So we're going to write 65 here. What is important? Number 40 is important for us. Why is that? 40 plus 65 gives us the minimum value of the second class, which is 105. So 65 plus 40 gives us 105. 105 plus 40 gives us the minimum value for the next class, which is 145, and so on. So the next class starts at 185, and the other class starts at 225, and the next class starts at 265, and finally the last class starts at 305. By adding 40 to the lower limit of each class, we get to the last class. Okay, very well. So what is the maximum value then? Okay. The maximum value of your first class is going to be 104. Why is that? Because classes have no overlap. The very first class starts at 65 and stop at 104. There is no overlap between these two classes. They are different classes. The second class starts at 105 and it stops at 144. There is no overlap between these two classes. The third class starts at 145 and stop at 184. There is no overlap between these two classes. Well, the fourth class starts at 185 and stop at 224. Your next class stops at 264, and this class stops at 304, and finally your last class stops at 344. Guys, take a look at the difference between these numbers. 104 plus 40 is 144. 144 plus 40, 40 is your class width, is 184. 184 plus 40 is 224, and so on. So the difference between consecutive upper limit of classes is 40, the difference between consecutive lower limit of consecutive classes also 40. So that way you build each class. We build each class, and now we need to count how many numbers are in between 65 and 104 inclusive. Let's take a look at our notes. Okay, we need to start counting 65 to 104. Okay, 100 is included, 90 is included, 85 is included. It's between 65 and 104. 65 is included. What else do we have? We have 80, and then we have, let's see, what else? 90. So it seems like the frequency is 6. There are 6 numbers between 65 and 104. That is the frequency of the first class, or the count of the first class is 6. If we keep going, if we keep continuing this process, we can see that there are 9 numbers in between 105 and 144. Just the count or the number of values in between. The number of values between 145 to 184 is going to be 6. The number of values between 185 to 224 is 4. The number of values, or the number of count of the numbers between 225 to 264 is going to be 2. Just one number is in between 265 to 304 inclusive. And finally, the number of values between 305 and 344 is 2. So these numbers are called the frequency. If you add them together, the sum is 30. With 30 values in our collection, remember that. Take a look at our example here. Remember, we had 30 portable global positioning system navigators prizes, 30 prizes. So if we add the frequencies together, it must be equal to 30, which we see it is true. 6 plus 9 plus 6 plus 4 plus 2 plus 1 plus 2 is 30. Well, in step 3, you're going to find the midpoints. Step 3, midpoints. To find the midpoint, you're going to take the lower limit and upper limit of each class, add them together and divide it by 2. You're going to find the middle number. So midpoint is lower limit plus upper limit divided by 2. Okay, it shouldn't be that difficult to find the midpoint. We want to know what is in between 65 and 104. So what are we going to do? We're going to add these together. 65 plus 104 and then divide it by 2. This number is 84.5. Now the midpoint for the second class, the same process. We're going to take the lower limit, the upper limit, add them together, divide by 2. So 105 plus 144 divided by 2, which is 124.5. Guys, see the relation here. See how we get to the next number. The difference between 84.5 and 124.5 is just 40, as we expected. You can add 40 to each one of these numbers or do the algebra. The next number is 164.5, the middle number in between the lower limit and the upper limit. If I add 40 to it, I get 204.5. Next, 244.5, 284.5, and finally 324.5. Okay. So far, I built each class. I found the frequency for each class. I found the midpoint for each class. Now I'm interested in knowing what is the relative frequency. To find the relative frequency for each class, you're going to take the frequency of that class and divide it by the sum of all frequencies. So this is our step 4. Step 4, relative frequency. R sub f is equal to the frequency of that class divided by the sum of all frequencies. Okay, so show us, how do we do the calculation? The relative frequency for the first class is 6 divided by 30. So we have 6 divided by 30. You can leave it as decimal or as percent. It's 0.20 or 20%. The relative frequency for the next class, we are doing the same process. What is the frequency of that class? It is 9. Divide by what? Divide by 30. So 9 divided by 30, which give us 0.30 or 30%. Relative to the rest of the classes, 30% of your data is in between 105 and 144. The next one, 6 divided by 30, which is just 20% again, and we continue this process. So 6 divided by 30.20, and here we have 4 divided by 30, which is 0.13. Then we have, let's see, 2 divided by 30, which is 0.07 or 7%. 1 divided by 30, which is 0.033%. And again, you have 2 divided by 30, which is 0.07 or 7%. Now that we calculated the relative frequency, we want to know what is the cumulative frequency. The cumulative frequency is easy to calculate. The cumulative frequency of the first class is equal to the frequency of that class. So it's going to be 6. The cumulative frequency of the second class is going to be the sum of previous frequencies. 6 plus 9, which is 15. So we're adding previous frequencies together to get to the next cumulative frequency. So in this case, you have 6 plus 9 plus 6, which is equal to 21. The cumulative frequency for the next class is 25. Then you have 27, 28, 28 plus 2 gives us 30. Just note that the cumulative frequency of the last class must be the same as the number of data in your collection. These two numbers must be the same. If they are not the same, it means that we made a mistake. Very well. So this is called a frequency table. What's the use of a frequency table? We can use these classes and graph these data based on the classes that we have. Let me quickly show you how to graph these data using the classes that you have. Frequency histogram. In a frequency histogram, you have a horizontal line representing the classes. And you have a vertical line representing the frequency or count. Okay, how many classes do we have? We have 1, 2, 3, 4, 5, 6, 7 classes, am I right? So 1, 2, 3, 4, 5, 6, and 7 classes. From 65 to 105, 145, 185, 225, 265, 305, and it stops at 344. The maximum value is 9, so let us have it scaled at 10. Very good. Our first class has height equal to 6. So the height of the first class is 6. You're going to use a bar which has height 6. It represents the number of values in the first class. The height is 6, the frequency is 6. The second class has height, ceiling stops at 9. So we're going to just move the second bar and the height is going to be 9. Okay. For the third class, the height is 6. So you're going to have a bar, a rectangle that stops at 6. And then you have the fourth class with frequency 4. Very good. So this guy stops here. The next class has frequency 2. Then this class has frequency 1, so it's not that high. And finally, the last class with frequency 2. This is called the frequency histogram. Well, by looking at the histogram, we can measure the center. Well, we can measure the center. How? The center is going to be where the classes balance. What else I can do to find the center? Is there any way that I can accurately measure the center? What you can do, you can take all of these numbers, add them together, and divide by 30 to find the center. That way, it gives you the best estimate. So the center, in this case, if you want to find what the mean is, you're going to add all prices and divide by 30 to find the center of your data. We expect the center to be around the very first part of our graph because that part balances the best.